So we did A, B, and C yesterday, and now we'll take a look at D. So we got to graph that equation, and you'll notice that the exponent on x plus 1 is, the exponent is 5/3. So we're transforming the equation y equals x to the 5/3. And I believe we graphed that on page 1 or page 2 of the notes. Maybe we didn't. But it'll be similar to this graph down here, okay? Y equals x to the 7/3. Okay? It'll snake through the origin, okay? So down here at the bottom, let's draw a crude graph of y equals x to the 5/3 so we know what we're starting with. So here's the coordinate plane, right? X and y axis. And the graph of y equals x to the 5/3, right? Snakes through the origin. Something like that, okay? And so this equation up here, D, is a transformation on this equation, y equals x to the 5/3. Okay? And so we can graph this equation, right, by performing the appropriate transformations on this equation. So we start off with y equals x to the 5/3. Well, notice in parentheses, we have x plus 1 raised to the 5/3. So we can replace x here with x plus 1. And you know that when we replace x with x plus 1, it takes this graph down here and shifts it to the left 1 unit. So we shift left 1 unit, okay? Sorry that it doesn't read, but you guys can still read that? Okay, in the back? Okay. All right. Then, right, then we have a minus 1 out here, minus 1 times x plus 1 to the 5/3, okay? So we multiply the right-hand side by minus 1, or minus sign, and we have minus x plus 1 5/3. And you know when you multiply the right-hand side by minus 1, right, or take the negative of it, it flips the graph over the x-axis. And we reflect across the x-axis. So we take this equation, we take this graph, excuse me, we shift it to the left 1 unit, and then we flip it over the x-axis. This is y equals x to the 5/3. And so when we replace x with x plus 1, right? instead of snaking through the origin, it's going to snake through the point -1, 0. So here's -1 on the x-axis. And so now it's going to snake through the point -1, 0 on the x-axis, okay? We shift it to the left 1 unit. And now when we multiply the right-hand side by -1, it flips the graph over the x-axis. So here's -1 on the x-axis, and now the graph comes down, and I'm doing this by hand, so. And now it snakes through, still snakes through, right, at x equals -1, but the graph is flipped upside down. Okay. So this is y equals minus x plus 1 to the 5/3. And that's our final graph. So any questions on transformations, assumptions, and their graphs? Okay. You'll get plenty of practice with the WebAssign at home. Okay. All right. So you flip over your page. You have two equations that transform functions. Okay. And we got to find the x and y intercepts. Okay. So, you know what, these I'm going to do on the board. Okay. So the first equation on the left, we have y is equal to x to the 2/3 minus 4. So finding the y-intercept is the easiest. Remember how to find a y-intercept? Set x equal to 0 and solve for y, right? Set x equal to 0, solve for y. So we put 0 in for x up here. Y is equal to 0 to the 2/3 minus 4. And 0 raised to any real number is 0, except for 0. 0 to the 0 is undefined. Okay. But 0 raised to any non-zero real number, okay, is still 0. So this is equal to 0 minus 4. So y equals -4 is the y-intercept, which is the point 0 minus 4 in the coordinate plane. So WebAssign might ask for one way of expressing the y-intercept over the other. To find the x-intercept, we set y equal to 0 and solve for x. So we set y equal to 0 over here. we have x to the 2/3 minus 4. So I'm solving for x, right? We add 4 to both sides. Right, we gotta isolate the x. We have 4 is equal to x to the 2/3, or x to the 2/3 is equal to 4, right? I just switch the two sides of the equation. But we haven't discussed much the rules of exponents yet this semester, but I'm sure you're familiar with them. But let's remember that x to the 2/3 is equivalent to the cube root of x squared. Right. 3 is the root, 2 is the power, okay? Is the exponent on variable x under the cube root. Well, what undoes cube root? Cubing. So we cube both sides. Cubing undoes the cube root just as squaring undoes the square root. Okay. And we're left with x squared is equal to 64. And now you take the square root of both sides. And we have the square root of x squared is equal to square root of 64. What goes in front of the square root of 64? Plus or minus. And we have x is equal to plus or minus 8. So x equals minus 8, where the point minus 8, 0 is an x-intercept. And x equals 8, where the point 8, 0 is an x-intercept. So let me show you why that is. On page 2, we graph the equation y equals x to the 2/3. Right, and it looks like this. Okay. Right, the vertex is at the origin. So when we subtract 4 from the right-hand side, what does it do to the graph? Goes down 4 units, right? And so when it goes down 4 units, so here's y equals minus 4. When it goes down 4 units, the graph ends up crossing the x-axis in 2 locations. 8, 0, minus 8, 0. Okay. That's how come we have, right, with the original equation, we only have one x-intercept, right? It touches the x-axis at the vertex. But when we shift the graph down 4 units, now the graph is crossing the x-axis in 2 locations. Okay. In the back, can you? Okay. All right. Any questions on that? All right, let's do B. And y is equal to 3 plus x minus 2 raised to the minus 2 power minus 1. Okay? All right, so again, we're find the y-intercept. Set x equal to 0 and solve for y. So y is equal to 3 plus 0 to the minus 2 power minus 1. Three plus 0 is 3. 3 to the minus 2 is the same as 1 over 3 squared. 3 squared is 9. And 1/9 minus 1 is minus 8/9. So y equals minus 8/9, or the point 0 minus 8/9 is the y-intercept. Okay. Any questions on that? To find the x-intercept, we set y equal to 0. And so when we set y equal to 0, we end up with 3 plus x to the minus 2 minus 1. So you can add 1 to both sides. You get 1 is equal to 3 plus x to the minus 2. Well, 3 plus x to the minus 2 is 1 over 3 plus x squared. And now we multiply both sides by 3 plus x squared. And we get 3 plus 1 times 3 plus x squared is 3 plus x squared. And on the right-hand side, we have 1. Okay. So this is shaping up to be a quadratic equation. So when we FOIL 3 plus x squared, we end up with 9 plus 6x plus x squared is equal to 1. And now I can subtract 1 from both sides, and writing the left-hand side in descending powers of x, I have x squared plus 6x plus 8. Well, that factors into x plus 2 times x plus 4. And now by the zero product property, one of those factors has to equal 0. So either x plus 2 is equal to 0, or x plus 4 is equal to 0. So solving the first equation, we get x is equal to minus 2. Solving the second equation, we get x is equal to minus 4. So those are x-intercepts, location of x-intercepts on the x-axis. X equals minus 2 is the point minus 2, 0 on the x-axis. And x equals minus 4 is the point minus 4, 0. So those are the x-intercepts, okay, in the graph of this, in the graph of the function in B. Okay. Any questions on that, ladies and gentlemen? So now you have everything you need to successfully complete the web-assigned homework. So now we're going to move on to hopefully what is some lighter fare. Linear functions, which just involve, right, a straight line. So I remember studying the equation of a straight line in high school. I think it's like the first kind of equation that you learn about. All right. So we're going to go from just talking about linear equations to what are called linear functions. Okay. A function f defined by a linear equation, y equals f of x equals mx plus b, okay, where m and b are constants, is called a linear function. Okay. Because if you remember slope-intercept form for the equation of the line, this is slope-intercept form on the right-hand side, right? Mx plus b. So let's review quickly how you calculate the slope of a line. This area right here. So here's my coordinate plane. And I'm doing this in the first quadrant just out of convenience. Okay. And so here I have, right, the graph of a straight line. And it passes through these 2 points. This equals x1, y1, right? So the x coordinate for this point is x1, the y coordinate is y1. The x coordinate for this point is x2, the y coordinate is y2, and the steepness of the line, right, slope is another word for steepness, the steepness of the line is the same at every point on the line. It doesn't change, okay? And so the slope or the steepness can be expressed as rise over run. Okay. So the rise is how far you got to go vertically, right? And going from this point to this point, the rise is how far you got to go vertically. And then the run is how far you got to go horizontally to go from this point to this point, right? So to go up this many units, which is called the rise, and then we go over that many units, which is called the run. Okay? So rise over run gives us the steepness of the line, and we call that the slope. Okay? Well, this vertical distance from here up to here is equal to the difference in the y coordinates. And this distance from this point here over to here is equal to the difference in the x coordinates. So you often hear people saying slope is equal to change in y over change in x, right? Because we're subtracting. All right. We're going to look at 4 different lines under 4 different conditions for the slope. The first condition is the slope is greater than 0, right? Means it's positive. And if the slope is positive, then the graph of the line goes up from left to right. And so I call that going uphill. Okay? Because in mathematics, we read a graph from left to right. Okay? So we'll go from left to right, the graph of the line is going up. And so we call it uphill, and so that has positive slope. If m, the slope, is negative, less than 0, then the graph of the line is going down from left to right. Okay. I call that downhill. So if the line is going downhill, right, it has negative slope. Steepness is negative. And in the third scenario, the slope is 0. Okay. What kind of a line do we have when the slope is 0? Yeah, it's horizontal. It's perfectly flat. Okay. You can say there's no incline to it, right? It's perfectly flat. And lastly, there's a line where the slope is undefined. Slope doesn't exist. What kind of a line has an undefined slope? The vertical line, right? Straight up and down. Okay? All right, as I pointed out, the slope of the line is a measure of the steepness of the line. Greater the slope in absolute value, the steeper the line is. Okay? All right, there are 2 forms for the equation of a line. There is the point slope equation of a line. So the line passes through the point x1, y1. M is the slope. And so you can write the equation of a line in this form, right? Y minus y1 is equal to m times x minus x1. The other form of the equation of a line is called slope-intercept form, where m is the slope and b is the y-intercept, right? Where the graph of the line crosses the y-axis. It's y equals mx plus b. Mathematics, we use the second one quite extensively over the first one. But we often have to write an equation in point slope form, and then we simplify it to write the equation in slope-intercept form. Okay. So let's take a look at the first example. You're going to find a slope and the x and y intercepts of the given line. So you notice the given line isn't written in either point slope form or slope intercept form. You have 4x plus 5y is equal to 9. This is actually what is called the general form for the equation of the line, right? This is x to the first power, y to the first power, okay? In each of those terms. So this is a linear equation, okay? And it's written in what's called the general form, okay? So we got to find, in the graph of this line, what the slope is, okay? And where it crosses the x-axis and where it crosses the y-axis. So to find the slope, we're going to solve for the variable y. You get its slope-intercept form. So first step, I'm going to subtract 4x, right? We're going to isolate y on the left-hand side. So we're going to subtract 4x from both sides. And we have 5y. And I'm going to put the minus 4x in front of the plus 9 because I want to write this in slope-intercept form. And now to isolate y on the left-hand side, I got to divide both sides by 5. So the 5's cancel on the left-hand side, all right? They're common factor in the numerator and denominator. And when 5's cancel, I'm left with y on the left-hand side. Now, this is where I got to preach a little bit, I guess. Fraction bars are like division symbols. Division does not undo addition. Okay. On the exam, I see this all the time. People will divide like minus 4x by 5, but not 9. Or they'll divide 9 by 5, but not the minus 4x. You gotta divide each of those terms by 5. So this is equal to minus 4x over 5 plus 9 over 5. Minus 4x over 5, I can take the x in the numerator and pull it out to the right here of the quotient, the fraction. Then minus 4/5 times x plus 9/5. So this is, our line is now written in slope-intercept form, right? Y equals mx plus b. So lining up the right-hand side here with the right-hand side here, you can see the slope m is equal to minus 4/5. And where the graph crosses the y-axis is, right, b is the y-intercept. Where the graph crosses the y-axis is at y equals 9/5. It did ask for the y-intercept. So b is equal to 9/5, and that's the y-intercept. So we can write the y-intercept is y equals 9/5, or the point 0 9/5. Okay. All right, now to find the x-intercept, we got to go back to original equation. Now you could use this equation and solve for x, right? Set y equals 0 and solve for x. But then you're going to be dealing with these fractions. So I think we better go back to the original equation. set y equal to 0, solve for x. Okay. So to find the x-intercept, where the graph crosses the x-axis, go back to our original equation. We set y equal to 0. Five times 0 is 0. So we're left with 4x is equal to 9, or x is equal to 9/4. So the graph crosses the x-axis at x equals 9/4, which is the point 940 in the coordinate plane. Okay. Any questions on that? So our line crosses the y-axis at 9/5. That's almost y equals 2. Comes a little short. So there's where 9/5 is on the y-axis. And then where it crosses the x-axis is 9/4. That's a little more than 2. It's like right here is 9/4. So that's what the graph of our line looks like. Okay. All right. Any questions on that? All right, so you flip over your page. Find a point slope equation of the line passing through the points -1, -2, and 2, 5. So we're given what form we have to write the answer in.
Point slope.
Yeah, point slope. So the line passes through the points -1, -2, and 2, 5. So in the coordinate plane, here's the point -1, -2, right? X equals -1, y equals -2. And the point 2, 5, here's x equals 1, x equals 2, y equals 5. Right, so there's the point 2, 5. And this may not be drawn to scale, okay? It almost certainly doesn't go through the origin. But the line looks something like this. The graph of the line looks something like that. Okay. So to find the slope of the line, label one point x1, y1, the other one x2, y2, and then slope is the change in y over change in x. y2 minus y1 in this case is 5 minus a -2, and x2 minus x1 is 2 minus a -1. 5 minus a negative 2 is the same as 5 plus a positive 2. And 2 minus a negative 1 is the same as 2 plus 1. So the slope is equal to 7 thirds. Alright, now to write the equation in point slope form, you could actually use either of those 2 points to write the equation in point slope form. But I labeled this point here x1, y1. So substituting for x1, y1, and m, we have y minus a negative 2 is equal to 7 thirds times x minus a negative 1. And now you should simplify. Minus a negative 2 is plus a positive 2. And minus a negative 1 is the same as plus positive. Now, so that's one way of writing it. Now, if you switch it and label this point x1, y1, okay, then the equation of the line in point slope form would be y minus 5 is equal to m 7 thirds times x minus 2. Both of those are valid, okay? If you simplify, solve both those equations for y, you get the same equation in slope-intercept form. Okay. All right. Any questions on that? All right, so let's do attendance, and then we'll finish this thing off on Friday. And then this homework will be due on Tuesday. All right, Laura, Cade, Sam, Madeline, Dallas, Anders, Sophie, Sophie Croy, Kirsten, Grace, Navia, Jake, Bronwyn, Aliyah, Aliyah Gibson. I keep getting it wrong, don't I? I'll get it right before the end of the semester. Mia. Here. Joe. Here. Brianna. Here. William James. Enzo. Here. Annabelle. Here. Alex. Here. Cole. Here. Kayla. Here. Hayden. Here. Claudia. Here. Angelica. Angelica Rogers. Melissa Centerfight. Diego. Here. Hannah. Here. Haley. Here. Jeffrey. Here. Oliver. Here. Amaya. Here. 6. Have a great day. I'll see you guys Friday.